Okay, so we're moving on to hyperbolas. Okay, if you'll remember with hyperbolas, when we first discussed why they're called conic sections, I said if you had two cones whose tips were touching and you slice this down, you would actually get two different pieces, one from each cone, and they kind of look like parabolas facing in opposite directions. So a hyperbola has two parts to it, and as you can tell just from this diagram here, they're pretty complex. Lots of different pieces to them that we'll talk about, but they're kind of fun to graph because of all those pieces. So, as with ellipse, we can have vertical and horizontal. So if it's a vertical hyperbola, it will have two curves, one facing up, one facing down. So let's make a little note that this is vertical. And then if it's horizontal, they still have two curves, one facing right, one facing left. So that will be what we call a horizontal hyperbola. Just look at the equations and tell me how they're similar to what we just did with the ellipse. See any similarities? There's a minus in the middle. Okay, and one other difference, the a squared is always with the positive term. Now when I say positive term, that's the one that's not being subtracted. I'll call this the negative term and this the positive term. The one that's being subtracted is the negative. So with this one, a squared is always with the positive term, and we'll write that down in our notes in just a minute. And then you'll be happy because the Pythagorean relationship here is a squared plus b squared equals c squared. So that's not different and weird like it was with the hyperbola. Alright, so let's go to our notes. A hyperbola is the locus, means location of points, such that the difference of the distances from any point on the hyperbola to two fixed points remains constant. These 2 points are called the foci, just like with ellipse. D1 minus D2 in that picture, this distance minus this distance, remains constant for all points on the hyperbola. So if you'll remember with an ellipse, those two distances from foci to foci were the same if you added them. These are the same if you subtract them for a hyperbola. Alright, so here's our horizontal, opens left and right. Here's our vertical, opens left and down. Up and down. Alright, what do you think we call this point right here, smack dab in the middle? The center. Right? Now, this one is at the origin, you're right. They won't always be, but that will be our center point. And guess what we use for it? HK. Just like we did with the circle, just like we did with the hyperbola, and same for hyperbola. Same as ellipse. Got my words totally mixed up there. Okay, HK is the blank of the foci. What do you think goes there? Midpoint. Yeah, just like before. Okay, the vertices are the turning points. Okay, so the vertices, I'm just going to put a V so it doesn't get too cluttered, are right there. That is a vertex, and that is a vertex. So it's kind of like the vertex on the parabola. It's where the parabola turns. This is where these turn and go back the other direction. And they are A units away from the center. So that's the same also. Vertices are distance of A. One in the positive, one in the negative, so we could say plus or minus A, because we'll either go left and right that amount or up and down that amount. So over here on this right side one, this is a vertex and this is a vertex. Those points right there that would also be called a vertex on a parabola, we call them the vertex here. The co-vertices are these, I'm going to put co-V, and these. And it's a similar distance, we call it B units away from the center. Okay, we have two axes. We have the transverse and the conjugate. The transverse axis connects the vertices and has a length of, okay, we'll fill that in a minute. Let's see, I'm going to get a different color here. So here's a vertex, here's a vertex. This axis that goes through them is called the transverse axis. Over here on the vertical one, it's the axis that goes through the vertices. So this is our transverse axis. Now, if this was A and this was A, then how long is that axis? 2A. Okay, the other distance connects the two co-vertices, and it's called the conjugate axis. So conjugate axis will go here. And here. And so if this distance was B, and this distance is B, then this length is 2B. Okay, so this is kind of the weird part about these. They have asymptotes. Do you see these dotted diagonal lines? On a graph, we usually dot the asymptotes because they're not part of the curve, but they sort of define where the curve goes and gets closer to. So the asymptotes are the diagonal lines that guide the curves. They'll tell us how wide or narrow to make these curves. Sometimes they'll be really narrow, sometimes they'll be very wide. It all depends on those diagonal lines. The foci are C units away, left and right or up and down, so I'll say plus or minus C units from the center. Now on our graph, the foci are here and here. So notice that they are inside the curves. So if I'm thinking of that as kind of like a parabolic curve, the focus is inside of it. Focus is inside of this. So that means that C is greater than A, because this distance to focus is called C, just like it was before. Here's my focus here. Here's my focus down there. Okay, so the focus are inside the curves. Okay, formula to find C is C squared equals A squared plus B squared. Okay, standard form for, I'm writing this under horizontal, I'm just taking it off that formula sheet, is x minus h squared over a squared minus y minus k squared over b squared equals 1. For a vertical, the y term is positive, and the x term is negative. Okay, notice here that a squared is with the positive term. A squared under positive term. B squared might be bigger in these. Different rules than with ellipse. Okay, the transverse axis will be y equals k. X equals h over here. That's that horizontal line here or vertical line here. The conjugate axis will be x equals h. And over here, y equals k. Those are exact opposites. And the asymptotes, here we go. So we're going to have to find these diagonal equations. And here's our formula that we will use to find them. Y equals positive or negative b over a, x minus h plus k. Y equals plus or minus a over b, x minus h plus k. Lots of parts to these. Graphing them is pretty simple, though. Believe it or not. Okay. Are we good? Got all this down? Okay. Let's look at how to graph these things. All right. So, underneath the positive term is your a squared. Underneath the negative term is your b squared. Now, this is sometimes different from ellipse because with ellipse we said a squared is always the biggest. In this case, a squared is always the positive denominator. Okay, so if a squared is 4, a is 2. And if b squared is 25, b is 5. Where's the center of this one? What's added or subtracted to x and y? Nothing. So the center on this one is 0, 0. Okay, that's where we're going to start. Plot the center point. Okay. Under the x is 4. The square root of 4 is 2. So that means in the x direction, we go 2. So I'm going to go right 2 and left 2. Make a point. Okay, under the y term is a 25. Y-axis goes up and down. Square root of 25 is 5. So I'm going up 5 and down 5 from the center. That's no different than the ellipse, right? If this had a plus in between it, I would connect it. That would be my ellipse. But it's a minus, so it's not an ellipse. So this is what we do. See those 4 points? I'm going to make like a rectangle out of them. If you'll notice, there was a little dotted rectangle on these pictures. I don't usually like to dot the whole rectangle. I will just go and mark the corner points. But if you want to dot the whole rectangle, that's perfectly fine. Okay, so I'm going to connect the diagonal of this box, and those are my asymptotes. So get your ruler, and I'm going to use a different color than what I'm graphing in here. Well, I'll just graph the curve in a different color. So I'm going to dot the diagonal. There's one asymptote. I'm going to dot the other diagonal, and that will be the second asymptote. Okay, so far we plotted the center, we went out A, we went out B, made the rectangle, dotted the diagonals, which are the asymptotes. Okay, now the only thing left to graph the curve is to sketch it. So if x is positive, if x term comes first here, it is a horizontal, x-axis runs horizontal, so will my curve. So this point that I went out to here will be the vertex. And I'm going to draw, this is a really wide curve because I'm going to go out and approach the asymptote. So if this asymptote was really close in, it would be narrow, but these are really wide because the asymptote is kind of far out. So that thing that I just graphed in pink, that's the actual hyperbola. Okay, so when I'm listing the vertices, those are the 2 points. Remember on the front page, the vertices are the turning points of the curves. It's where I started my curve, going up and down on both sides. So that ordered pair is 2, 0. And the one over there is negative 2, 0. Okay, the co-vertices are those other points that formed the rectangle. So that's 0, 5, and 0, negative 5. Okay, to find the foci, we're going to have to find the c value. So we're going to say c squared equals a squared plus b squared. C squared is 4 plus 25 which is 29. So C is the square root of 29. Okay, the focus, remember, is inside the curve. So that means the focus is somewhere out here to the right and out here to the left. Okay, well, square root of 29 is a little more than 5. So I'm going to go a little more than 1, 2, 3, 4, 5. There's a focus. 1, 2, 3, 4, 5, a little more. There's the other focus. Inside the cupped curve. So what is that ordered pair? Well, it is same as we did before. We're starting at the center point, but I'm going left and right square root of 29. So I'm going to add it to the x coordinate just like I did before, and then don't change the y. Of course, you don't need that 0 in front of the square root of 29, but I'm going to leave it there to remind you that we added it to the x coordinate. And then lastly, the asymptotes. Okay, go back and look at our little formula for it. This one is horizontal, so it's going to be plus or minus b over a x minus h plus k. I'm going to write this over here first. And I'm going to show you why it's b over a and what that represents. Remember, h and k are your center point coordinates. Okay, if I ask you to write the equation of this line here, we would need to know the y-intercept and the slope. Well, the slope of this dotted line, I can count rise, 1, 2, 3, 4, 5, over run, 1, 2. So 5 over 2 is the slope of this line going up to the right. Well, 5 over 2 is your b over a. And then this slope, I would rise 5, run negative 2. So that makes that slope negative 5 over 2, or negative b over a. So that's what that number is out front. That's your slope. And this is just a point slope form of a line. Just another way of writing the equation of a line. So I'm going to have plus or minus 5 over 2, x minus h was 0, plus k is also 0. Now, I am fine if you want to leave your equation like that. Or if you want to distribute and get the full y equals mx plus b, then those zeros aren't going to change anything, right? It would just be y equals plus or minus 5 halves x. So you have that positive slope of 5 halves, negative slope of 5 halves, representing each of those asymptotes. It's a lot of stuff, isn't it? Question on that one before we jump into another one. All right. Okay, here we go. Positive denominator is a squared. So if a squared is 36, what is a? 6. This is b squared, 9. b is 3. What's the center of this one? It's still 0, 0. I don't have anything added to x or y. So that'll make it relatively easy. Okay, plot the center point. Go out A, go out B in your two directions. Will I go right, left, or up, down 6? Up, down, because it's under the y. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This 9 is under the x term. X-axis goes left, right, so I'm going left and right 3 from the center. And those 4 dots are going to form that box. Either dot the whole box or just figure out where your corners are. Take your ruler. We're going to dot those diagonals, which become the asymptotes. That'll dictate how wide or narrow. Okay, so far, plotted the center, went out A both directions, went out B both directions. That creates a rectangle. Dot the diagonals, those become your asymptotes. Okay, next, is this vertical or horizontal? What's the positive term? Y. If the positive term is Y, then it is vertical. So I will draw the hyperbola starting at this dot, going up. This one is not nearly as wide as the last one. And then I'll go to that dot and connect it going down. Okay, well those dots that I just started from, those are the vertices. So this vertex is 0, 6, and this one is 0, -6. Okay, these other two dots that help form the rectangle are the co-vertices. So that's 3, 0, -3, 0. Any questions so far? Okay, to find the foci, we have to find what variable? C. C squared equals A squared plus B squared. C squared equals 36 plus 9, which is 45. So C is the square root of 45. Now that does simplify because 45 is 9 times 5. So that can also be written as 3 square root of 5. Or you can leave it square root 45. Okay, and we will use that to write the foci. Okay, so square root of 45 is more than what? More than 6. So let's go a little more than 6. And a little more than 6 inside the curves. And that's the location of each focus. Now, what's that ordered pair? Well, we started at the center. Did I add that number to the x or the y coordinate of the center? The y, because we went up and down. So the x doesn't change. The y will have a plus or minus square root 45. Or 3 square root of 5 if you want it simplified. Okay. All right, asymptote for vertical. One thing is different. Your slope is A over B instead of B over A. And again, it's just the rise over run from the center to the corner. Okay, so plus or minus A over B x minus h plus k. All right, so let's put that over here. Y equals plus or minus 6 over 3, which is 2 x minus h plus k. Or just y equals plus or minus 2x. So you have the positive 2x for the slope that's positive, negative 2x for the slope that's negative. Question. All right, you want to try this next one?
No. Walk us through it.
All right, walk you through it. What's a squared?
4.
Okay, yeah, it comes from the 16, so a is 4. A squared is 16. It's always with the positive term. What's b squared?
1.
1, yeah. If it helps you, put a 1 under there. So b is the square root of 1, which is 1. Okay, what's the center of this one? Anybody? 3, -1. 3, -1. Just like with the circles and the ellipse, we're taking the opposite of that coordinate there. Okay, so let's graph. 3, -1. Will I go up, down, or left, right, 4? Left, right, because that's under the x. X-axis goes left and right. By default, I'm going to go up and down 1, but it's because it's under the y term and y-axis is up and down. Ooh, that's a little skinny box there, isn't it? Okay, so we've got little corners here. Dot the asymptotes. Dot the asymptote. Okay. Is this vertical or horizontal? The curve itself. X is positive, so it is X positive, it's horizontal. Okay, so the curve will be formed from these two vertices that I went left and right. This is even skinnier than the last one. It's a little bitty narrow hyperbola because you're only going as wide as the asymptote will allow. Where it guides the curve. It serves as a boundary for the curve. Okay, so the vertices are those two dots that I started drawing from. Alright, well this is not an easy point to figure out. Oh, it is 2. Never mind. Scratch that. 1, 2, 3, 4, 5, 6, 7, -1. And -1, -1. Okay, the co-vertices are these two right here. So that's 3, 0, and 3, -2. Okay, foci we're going to have to calculate. So c squared equals a squared plus b squared. C squared is 16 plus 1, which is 17. So c is the square root of 17. Alright, so square root of 17 is a little more than 4. So from the center, I'm going to go 1, 2, 3, 4, a little bit more. And that puts the focus inside those curves. Okay, so this is the tricky one. It's not an easy point to figure out. So this is where we go from the center. Are we adding this square root of 17 to the x or the y? If I go left and right, it's adding to the x. So I take the x coordinate of the center, add and subtract square root of 17, and then the -1 is not changed. Okay, all right, this is horizontal, so I'm going to look back up here at this other horizontal one. There's the asymptote formula written out. So it's y equals plus or minus b over a, 1 over 4, x minus h, x minus 3, plus k. So if I wanted to distribute that out, this one's a little bit tougher, but let me show you how you would do it. Okay, I'm going to do the positive 1/4 first. I'm going to distribute 1/4. 1/4 x minus 3/4 minus 1. And then I would just have to add those two things together. Well, that's 4/4 minus 3/4 is 7/4. So I add 1/4 x minus 7/4. That's one asymptote. The other one, I would take the -1/4 and distribute. So I get -1/4 x plus 3/4 minus 1. Well, that's still 4/4. So that would be y equals -1/4 x minus 1/4. And that would be the other asymptote. if you wanted them in y equals mx plus b form. I don't care if you leave them like that. I'll trust that you know how to distribute. Ooh, it's a lot, isn't it? But they're kind of fun, ain't they? The little boxes and the diagonals and all that. All right, I want you to try this one for me. I'll work it out, but I'm not going to talk through it. So if you get stuck, peek up here. If you see me make a mistake or think I made a mistake, let me know. Oh, okay, so I lied. I'm going to say one thing. When you get your center point, make sure you get the x coordinate from the x term. So the center is -2, 4. Just make sure you're pulling from the right factor there. Talk to your neighbor if it helps. If you have a neighbor. Around if you have questions, stop me. If whichever one is positive, so the y term is the positive one, the curves will go up and down, just like the y-axis is up and down. Okay, how are we doing? Depending on whether it is vertical or horizontal. So this one is vertical because y is positive. So with the vertical, look down from here, there is your formula under the vertical one. Any other questions? Did anybody distribute and put asymptotes and y equals x plus b? You did? Awesome. Let's see if I have those. Did you get... Oh, okay. Do you want me to work through it? Switched your A and your B? Okay. All right. Any questions or comments? We're good. Okay, let's skip on down. Skip number 5. Let's work on rewriting them into standard form. Guess what we're going to have to do? Complete the square. Complete the square. So what we're trying to do is get it in this form or this form, but it's the same process that we used with the ellipse. Okay, so let's jump right into this one. Okay, so remember with the ellipse, we started out by grouping x's and grouping y's, right? So I'm going to do the same thing. I'm going to group x's. Oops, that's a 90. And then group y's. Now this is going to stay minus here, and I'm just going to have 16y squared. And then we want the number over there on the right. Eventually, we're going to turn that number into 1, just like with the ellipse. Okay, so do you remember with the ellipse what we did if there was a coefficient here? We factored it out, didn't we? Okay, so we're going to do the same thing. I'm going to factor out this 9. X squared plus 10x, leave your space. Now, there's really, I'm going to bring the 16 out there, but there's nothing else to factor it out of. Okay, so far, same as with the ellipse. Okay, then we do that weird little step. Take your 10, divide it by 2, that's 5, square it, and we get 25. So I'm going to add 25 right there. But I didn't really change the left by 25 because it's also getting multiplied by this 9. So what is 9 times 25? 225. So to balance it out, I've got to add 225 over here. Okay, there's nothing in here to take half of and square, so we're done with the y's. Next step, we're going to factor. What are my factors of x squared plus 10x plus 25?
5.
X plus 5 squared. Okay, nothing to do with the y's. And when I add that up, that is 576. That needs to be a 1, so I'm going to divide everything by 576. And let's do some reducing. Hopefully those reduce evenly. So 9 over 576 reduces to what? 1 over 64. So I have x plus 5 squared over 64 minus 16 over 576 is 1 over 36 equals 1.
How did you get the under 25?
Because this 25 that I added there really gets multiplied by the 9. Any other questions on that? So that's really not much different than the ellipse, is it? All right, let's try number 7. Should we take a quick 5-minute break?
Yeah.
Okay, let's take 5, and then we'll do a couple more of these, and then we'll be done. Pause this. Been doing a long time. He stood by his word. Okay, I think that this one looks kind of messy, so let's do this one here. All right, so tell me how I'm going to rearrange first. Move the y squared, leave the 287. Let's see. Negative 4x squared minus 56x plus y squared minus 6y equals 287. Oh, what's our positive term, x or y? The y's. So next I'm going to rearrange them. I'm going to group x's and group y's, but I'm going to put the y's in front because they're the positive ones. And then the 6y isn't, y squared is. Okay, group minus, okay, now this negative will cause trouble. It will wreak havoc. Be careful. This will be a positive 4x squared plus 56x equals 287. Be careful with those negatives. Okay, next step, if I have a factor like I do here, the 4, I'm going to bring it out. So on this one, I've got y squared minus 6y, leave your space, minus 4x squared plus 14x, leave some space, equals 287. Everybody okay? All right, we're going to take half of negative 6, which is negative 3. We're going to square it and get 9. Write it out if you need to. I'll fill it in. Negative 6 divided by 2 is negative 3. Squared is 9. But I did, oh yes, I did add 9. My bad. Plus 9 on the right. Next one, we'll have to do some adjusting. Okay, what's half of 14? 7 squared? 49. Write it out if you need to. But this negative 4 will multiply 49. And 49 times negative 4, oops, thank you. I couldn't seem to type that in correctly. Is that right? Okay, so next step, I'm going to do the factoring. Y minus 3 squared minus 4x plus 7 squared equals, let's see, 287 plus 9 minus 196, 100. Divide by 100. And one last step. This will be y minus 3 squared over 100. There's nothing to simplify there. But 4 over 100 reduces to 1 over 25 equals 1. Question? Barrett?
I just want to get where the y squared, like where the y squared goes. Like in between the second and third step. Yeah.
From there to there?
Yeah.
Okay, so remember y minus 3 squared means this. And if we FOIL that out or distribute that out, that's where it comes from. Any other questions? All right, let's do one more thing. Next page at the bottom, eccentricity. And that again is how rounded or narrow the curve is. It's a numerical evaluation of how narrow or wide the ellipse is. Not ellipse, hyperbola. It's the same formula that we use for ellipse. It's C over A. I think one of these will be enough. What do you think?
Yes.
Okay. So I need C and I need A. Which one looks bad? 11 through 14. Pick one. 14? All right. What is A? 6. Got half of it. Now I just need C. So I'm going to find C by doing C squared equals A squared plus B squared. So C squared is 196, 232. Let's square root that and see if that does simplify. I have no idea if it does. 2 square root of 58. Okay, so my eccentricity is C over A. Does that reduce? The 2 and the 6 reduce, right? So my eccentricity is square root 58 over 3. And that's it. And if I needed a decimal for that, let's see, square root 58 divided by 3 is 2.5. Okay. And if you'll look back up here, it says the ellipse was always between 0 and 1, but a hyperbola is always greater than 1. That's because that C value is bigger than A squared on this one. So we'll always get a fraction that's more than 1. Okay? Oh, homework. Let's see. I don't know that we need to do every single one of these. So how about we decide which ones we're actually going to do. I'm going to let these circulate. Okay. How about we do numbers 2 and 4. 2 and 4 on the front. And should we just stick with evens on the back?
Odds.
Odds on the back? That gives you one more than evens.
No, evens. Sorry.
Okay, evens. That's only 6 problems total.
Write the odds somewhere.
Evens. Okay? Alrighty, that does it.